Hello, hello. Hey Victor, hey Vishal, hey Adam. Hey Pierre, would you mind, are you going to be around the whole time? Would you mind potentially taking co-hosting again? Thanks. Yes, yes, I can hear you. Um, need to, let's, I'm going to, given the experience last week, I'm going to try and allow people to unmute themselves, but if this goes south quickly, I'll turn it back off. But we'll see if this can work a little better this time. It was, yes, but he's presenting next week, so hopefully that's not a terrible problem for us. I am going to turn off others' videos though, so it doesn't pop in away from the presentation. Do I do that? All right, everyone can see me at this point. I trust. Great. All right, so get going here. Thank you all for joining us again this week as we kind of figure out the process on all of this and how to make this better. Hey, Sean, good to see you. So a few quick announcements. This week we had a couple of social events that kicked off. One in Chicago. The Portland group continues to do theirs out there monthly. So uh, that went, I think, pretty well. We had about 25 people join us in person, which was exciting to see everybody. Thank you all who made it out to that. I highly recommend, again, anybody that is willing to do the effort of just calling up a place and announcing it to get people together, networking. Um, to by all means, please do so. Let us know if you want to set something up, and we can announce that and take care of some of that advertising for you on it, and try and get some more of these sessions happening around the globe. So next week, Victor will be presenting for us on some OpenMP. So looking forward to that. And the week after that, Matt Godbolt will be presenting an omnibus of the Advent of Code that he did. And I've got a couple of people that I'm talking to hopefully get on the schedule thereafter. Um, so stay tuned for some more info on that as we move forward. Today, I am One more thing I did want to mention, because I know he's uh, doing a lot of work in trying to help people in their interview processes and getting out and it's a big part of why I'm doing this is to help people get out and network and help companies find good candidates looking for jobs and stuff like that. And one of the reasons that I was able to kind of get this launched initially, just inspiration wise, is because Coding Jesus has offered some good advice and support, and wanted to give a shout out to his platform, getcracked.io. It's a platform that you can do practice questions on. Sorry, I had a say here. Where to go? If you're interested in breaking into the world of quantitative development or even just leveling up your skills, you can check out questions and problems on getcracked.io. If you're competitive, you can also check out the ranked quizzes that mimic online assessments. Content is available in both Python and C++. So I did want to give him the shout out there because he's been helping me out a lot on the back end of this. And yeah, so thanks a lot to him. And what I'm looking to do today is a bit of a continuation of what I started last week. So last week we went over what type erasure is and kind of like how to start our environments and stuff. And this was content broken out from a guest lecture I did for a class at the University of Chicago back in 2020. So the material there was very focused on C++ 2020, and I've gone back and kind of looked at it, and there wasn't a whole lot of updating that I sought to do with features that have been added since. But there is still some good conversations to be had out of this. So hopefully this gets us off and running with some fun stuff to look at, gets the brain kind of thinking about how some various language features can kind of be assembled together to make something a little bit more interesting, more expressive, a little more terse in your code. I've this week tried throwing up some code already um, on the Git repo. So if you check out the branch session 2026-0124 and so just tell me where, yeah, at this URL, which I will dump into the Discord chat as a reminder to people, the branch here being (2026-0124). So I've got some code up there already. I've actually put together a pretty brain dead makefile here to get us started. If you want to follow along at home, it's make setup env, which I've already done, so I'm not going to rebuild that myself. This assumes that you have micromamba installed per the I thought I had that in the README. This README. So let's get this in the I'll get this added to the main branch also, so that we don't have this issue in the future. Installation. All right, so inside that, if you pull latest on that, if you don't have micromamba set up already, it is really just that one line installation. And then the makefile will give you the, should have done, Written but not tested. All right. So I'm already set up on GCC 15 here, 15.2. Um, that is going to be the basis for what I'm looking at here. But we'll start off with a little bit of a talk about ADL. So actually, let me say first we'll talk about the namespaces. So I'll go to the namespaces one. And I know that this will be a review for a lot of people. We're going to have a variety of different experiences throughout this group. So I'm going to here be a bit more basic in some of these things just to make sure that we're all on the same awareness of what some of the features out there are and how they work in C++. So bear with me if this is pretty review for some of you, but this hopefully will help get all of us kind of on the same page as we go forward. So namespaces in C++ are a way to just manage the massive number of names that we end up generating throughout the language. They they're introduced to the namespace keyword, and then you give it a name. What this is going to do for us is allow us to introduce named names of all sorts of types that can be repeated in other namespaces without conflicting with each other. So here I have a namespace that I'm going to create a header and a message object. And what I wanted to point out here is that unlike classes, namespaces can be reopened. Did I really put this in one? Yeah, well, I did. So what we get here is that when I reopen this namespace, my namespace, and I'm creating or defining a struct message2, because at this point in my code, the compiler already knows of my namespace, everything that was in that namespace already comes into view with message2, which allows me here to just say that I want the header object HDR in my message2 also. So this is key mechanism of namespaces that distinguishes them from classes. So you don't instantiate a namespace ever. You just use that as a means to differentiate between the different names in your code. So not a lot to demonstrate with that other than it compiles, runs. There's no problem with that. So again, as opposed to a class, we can reopen them, which is nice. That also allows you to define objects within the same namespace across many files. And something you should definitely get used to doing, because as projects get much, much larger, you will definitely find yourself reusing the same names in different files. And if they're not in their own unique namespaces, then you're going to get into a lot of name collisions and refactoring headaches that you just don't want to ever have to deal with. To make this a bit more ergonomic in C++ 20, there was a rather small change to the language that was, in my opinion, a rather large ergonomic benefit. Rather simple features that we allowed sub namespaces to be defined using the qualified namespace aspect here. So what this is doing is I have a namespace called my protocol, and I'm going to have a sub namespace in that it's called v1. This replaces what we had to do prior, where I would say namespace v1 here, and then you end up indenting these things for every level, and it gets a bit cumbersome. But that's the same outcome or the same mechanic within the language. So instead of having to do that sub namespace, I can just qualify it with v1. here I have v2 and you can see that I can have header defined in each of them, message defined in each of them, but that won't be a problem because they are fully qualified as like oops. Oh yes, they would be fully qualified as like my protocol v1 message, or my protocol v2 message. What we can also do is pull in one namespace into another. So this is pretty useful when versioning protocols, and you want to have the ability to uh, specify what each of those message structures looks like within your code without sort of losing that knowledge to history. Maybe you want to support both protocols, but maybe you want to use one protocol by default. So a way that you can nicely express that is by having these sub namespaces like v1, v2, and then pulling the one that should be the default into the top level namespace. So now when I say my protocol messages text, that will be the message from v2 because v2 was pulled into my protocol. So when the compiler goes to look up message inside of my protocol, it will consider everything that is directly in that namespace, which because of this using directive will include everything that is in the sub namespace v2. So the compiler won't see this one at this point, but it will see that one. And try make that one, run that one. You can see it all builds and compiles and runs. I don't see any comments so far. Oh, good. Got quite a few people. Thank you again all for joining us. So that is a very quick overview of some namespaces, and we'll use that as a segue then to talking about a much more complicated language feature that has been around since forever, which is argument dependent lookup. You'll also just hear it by its acronym ADL, but the gist of argument dependent lookup is how we handle function call resolution in this world that we live in with all these namespaces, these names that can be everywhere. Like, how do you go about actually finding the function you mean to call? To demonstrate that, imagine we have two different namespaces, one that's defining all sorts of plants, one's defining all sorts of animals. And in plants, we have a tree, the tree has a name. Animals, we have a squirrel, the squirrel has a name. And we've defined a set of print functions for all of our things across either of those namespaces. And I want to be able to just say print and get the right thing printed. This is where argument lookup comes in, because what will happen here is that at the point we go to call that function, the compiler will look at the namespace we're currently in, and particularly when we're unqualified here. So notice I'm not saying animals : print, or animals : print, or plants : print. Instead, I'm just saying print. So this is what we call an unqualified call. The name is, the compiler is going to consider all names in our current namespace, and here we're in the global namespace. So it's going to consider all names in the global namespace. It's going to consider all names that are in any namespace of any parameter that is given to that function. So what this means here is that when we call this print and we're giving it this plants : tree, it will look at the it'll look at all names within that namespace as well. It won't look at this one because this squirrel is not handed to this print function, and instead it will just only look at that one. It looks there, inside plants, it finds a function named print, and the signature allows that to match, and so it will select that version of print. Here, we're passing a squirrel that is inside the animal's namespace, and so it'll consider the animal's namespace in that lookup. It'll find the print there and call print. Now there's a lot more to ADL than just this bit of it, but this is the part that is um, important to know for the further material. Note that we can also print it qualified, just to ensure that the right version of print is used. But that is a little bit redundant and unfortunate if we have to go about specifying that out. So this is much simpler, nicer, and the vast majority of the time it just works. But the feature is an important one to be aware of because when it doesn't work, it can be a bit um, traumatizing, I guess to put it that way, to figure out why maybe certain functions are being considered or not, certain names are being considered or not, to then hunt down what the order of um, priority is given if there's multiple names considered or when it's ambiguous or not. So, argument dependent lookup, ADL. Just to demonstrate that that is a thing. That yes, we indeed plant or print the plant, and then we print the animal, and then we print the plant, Sandy. Yes, I was a little more clever than I intended to be there, and missed that aspect of it. So what I'm doing here is I'm not just qualifying the print here, I'm actually telling it to use this version of print, even though it's outside the namespace of the parameters. So because I am being explicit. So it printed. This is, sorry, the it's a little bit of a tongue twister here. It printed the plant. It printed via plants print Sandy, which, as you can see, because of the duck typing and the fact that it's uh, a template here, that it doesn't. These definitions of print don't actually matter whether it is actually in animals or actually in plants. It will match to anything and then print it out, but it's selecting, by default, is selecting the version of print based on the namespaces. As soon as I was explicit here, I'm telling it to print Sandy, the squirrel, via the plant's print method, which is why it says plant here, but it still uses Sandy's name. Because this name here, plant T, is a guide for the reader, but that's not enforced. If I really wanted to enforce it, I would have to come up with some sort of a concept here that like is plant to enforce that I'm not accidentally printing something else. But now we're getting into concepts, which is a little bit beyond what I would like to do here. But the point here is that you can still select from outside of what ADL would consider by just fully qualifying it. Good question. And thank you. Because, yes, that was actually the intended point of that line. Sorry, can you say that again? Is no definition for what type? Mm-hmm. The point here is that this print will also work for an animal. Just because I use the word plant here is not that's not enforced that it comes from plants. So it just happens to be that squirrel matches here. So one way that I can demonstrate this issue is if I change this from to like animal name and make it so that squirrel and tree do not match in a duck type fashion. Now I will expect this to fail because there is no member on squirrel called name. There's only animal name. So that would now say squirrel has no member named name. But that's what's going on here is that it's selecting in this instance from two templates that both, the way I had this originally defined, both would work. Both versions of print would work for the either of those, as it just so happens. And if I wanted to enforce that print of plant would not happen for animals, I would have to come up with another mechanism, like using concepts or enable if or spin a if you wanted to go back to those techniques. Thank you. Does this make sense so far? Still, it you would not be alone in making that assertion. So ADL is a very powerful language feature, and it's been around since as long as I've ever known. I think it was I don't want to misattribute it, but because I don't have the information immediately offhand, I'm just going off of some rather old memory myself. But the gist of it is that you also probably aren't interested in trying to go and find the full qualification of the function that you just wanted to call on the thing. And so it's a bit of a trade-off in language design on the ergonomics of it in like 95, 99% of the cases versus the frustration when it doesn't go right. Right. So whether or not that was the best design that could have been done in hindsight uh, is certainly up for debate, I would say. But an example here that where this would come up, where you would get otherwise very frustrated with the ergonomics, is if you wanted to call, if you had like a string and vector, and you got strings s1 and s2, or std vector int v1 v2, then yeah, then calling something like is swap the right thing to demonstrate this here? It's like swapping s1 s2. I would need the better example here would be if I had a couple of objects that were in different namespaces. Everything here is in std namespace, so this is going to be a lousy off the cuff example. But if I had namespace and one, two, struct foo struct bar, and bar can be constructed with a foo, and here I'll reopen this and actually define foo to make sure that it is constructible from a bar. I have to say n1. Right, so now I've got two structures in different namespaces that I want to assign, or they are assignable between each other, right? So if I have n1 foo f and n2 bar b, I should be able to say f equals b or b equals f, right? Let's see if I did that right. Has incomplete type there. Do I really have to forward declare both? No, it has an incomplete type, which should be okay. Because it wants to make a copy of it at that moment, which it can't. So that's not actually what I wanted. Great. So now, if I want to do something like swapping B and F, then as long as I have the assignment operators, in theory that should be doable. You construct, I may not have everything else set up here, but I construct one in place, assign the as a temporary, assign the first, the second, assign the temporary back to the first, right? But if I had an overload of a function like swap that had to go off and find this thing, how do you resolve what namespace defines swap in? What if I define my own version of swap in n1 that takes any two functions and another one in n2? Then if I have a swap here that takes a t and an s for some two types, right? Then should that one get selected, or should this one get selected? If this one doesn't even exist, how do I make sure that at least the n2 one can get selected? Because relying on the developer to go out and figure out all those things is just going to be an ergonomic mess. How to do that all by itself. So that's why the ADL stuff is all out there and helping you out when you don't even generally realize it, right? Sorry if that's not the most detailed or obvious example, but it's gonna get hairy quickly without it. But yes, it does get very frustrating when it fails. Yeah, best practices around it. Sure. So going back into that file, then, and thank you again, everybody, for all these questions. This is exactly what I want out of these sessions. So the recommendation I would personally make is that if you are defining a function that is only operating on objects in a particular namespace, define that function down in that namespace space. Scope it as close to the things that you intend your function to work on as you can. Then if you're writing a function that is meant to work on things across a number of namespaces, truly really generic, then put it at the level where those objects are going to share a common namespace root. If you're getting into sub namespaces and all that stuff. So looking back at that protocol version of the namespaces, I think there was this file. Yeah. Yes. The more you can kind of shove your definition down toward the things that it's meant to operate on, then you're giving more information to the reader as to what you, the author, intended out of this particular thing you're writing. Like if I'm writing something and this operating on this protocol v1, and I have written it in a way that, like, I know that I'm operating on these things, I should probably put that functionality within that same namespace. Because if I put it up in the global namespace and then somebody comes along and creates something that looks very much like mine, and my global namespace stuff just happens to work duck typed on this new thing that somebody else wrote, you can very quickly imagine a third person coming along and not knowing whether or not the generic thing I wrote was meant to work on both of those or if it was only meant to work on one. So as a matter of expression, I would recommend putting things at the level that you were operating at when you wrote it. And then if you find it's useful, in a refactoring, you can always pull it up to a higher level. And at that point, put the thought into what else is up there at a higher level that you're trying to include or incorporate. And although I'll also qualify this a bit, that I bring to a lot of these discussions a long history in institutional development, where I'm like working within a particular company. I'm not one who's often worked across large public code bases, open source stuff, and things like that. I can definitely imagine you'd have a different set of considerations if refactoring is not an easy to do thing later on, right? Like you're going to want to put a lot more thought into exactly where the things that you're writing should live in consideration of what others may write down the line if you're sending it out to the world where you can't refactor it later. So my asterisk here is that my opinions here come highly colored in bias from the uh, the privilege of being able to refactor code pretty much at will. So your mileage may vary. That help? Great. And thank you guys again for these. This is good. It definitely makes it a lot less sort of dull sitting here talking to a faceless camera when I get questions. So thank you. All right, so namespace is ADL. The other feature that I wanted to go over here, which is one of my favorites of any language. And again, it's a simple ergonomic thing, but I just absolutely love it. When this hit the compilers, it made my life so much better. So it's called colloquially CTAD, it's meaning um, uh, template argument deduction. My brain just core dumped. The constructor template argument deduction? No. Template argument deduction. You're deducing the version of a template off of the compiler. Where is template argument deduction? Really? Class template argument deduction. Thank you. All right, so class template argument deduction. Sorry. I might actually try to edit that out in the upload. That's embarrassing. All right, class template argument deduction. When you have a template like tuple, how did this even? I compiled this all earlier. How would that have compiled? then the gist of it here is that with a template, I don't really want to have to tell the compiler what all of the template arguments are, particularly when that's redundant to what I'm about to hand to it. So tuple is a type that gives us one of each of a list of types. So it takes any number of types, and it's going to have one element, one data member for each of those elements, which lends itself to a constructor that takes the first element that's passed to it and pushes it into or the first parameter that's passed to it, pushes it into the first element in the data structure. Second element goes to the second parameter goes to the second element in the data structure, third, so on and so forth. So here I have an int, a double, and a string. Then, again, I'm missing all my includes. Historically, we would have had to explicitly said this, which was just obnoxious and redundant to the fact that I'm giving it an int, a double, and a string, and hey, those are exactly the things that the tuple needs to store. So ctad allows us to infer off of the constructor arguments what the actual template itself should be. So creating a tuple like this allows us to see that the type that we get, the type of t here, is exactly the same as tuple int double string. Would it also match tuple int const? No, it would not be the same there. So because here is same. I'm not decaying. Sorry, a question came in on the Discord I just saw. And I see now I've also missed a number of other comments from it. Yeah, great. Give me one moment. Yes, number of times we've all cried over namespaces in swaps. Class. When will swap use those? I'll hold off on talking about that just now, but yeah. So the static assert that we're doing here, taking the type of this, there's a question as to whether or not this would also match like tuple of with consts in this. So constant, and I will say that that should not, but let's prove that. Yep, so it's not const there, but I think I can force it to that if I say constant. I'm explicit here. Does that give me? No, it's not. Actually, that's not valid. No, because actually I think tuple decays the type because it's not going to store the type const. And so not there, but if I were to, let's drill into this a little bit more here. Template. Then let's get rid of that. Actually, what I want here is foo taking 5, 10, 20. And here I am expecting that this will actually be template argument one is invalid. What didn't like? Did I type in too many there? No. F. Oh. is it not liking here? Template argument. There are two candidates. Foo. I suppose one argument, 3 provided. Oh, I'm not saying foo. I'm saying tuple here. Foo. All right. Wrong number of templates 3 should be at least 0. Foo is not tuple. Yes. 3. What is it not liking here? Live coding. Wrong number of template arguments, 3. Should be at least 0. What kind of message is that? 3 is at least 0. Do I have this in the wrong spot? That in the wrong spot, don't I? I did. That was it. All right. So, going back to what we had. Come on, guys. Let me know when I got my dots in the wrong spot. All right. Okay. So, stack assertion failed. It's not the same. Decal type F. Line 12, static cast. Oh, to const? Does that give me the, it doesn't tell me why. It is. Don't we all love compiler messages? They've gotten a lot better. I gotta give them that. Static assertion failed. It still doesn't like the const. All right, so I am a smidge beyond my trivial knowledge on this. I thought this would, since it's bringing in a const ref. Oh wait, is that? No, it's not a const ref. There's no ref there. It's an R value. Foo of t's. Still doesn't like it. All right, so why isn't it? What I can do here, I believe, to trick the compiler to tell me what I want to know. Where equals off. So what I'm going to do here is I'm going to force an assignment because I believe that compiler message gives me more information than I want. Because operands are const, foo constant and foo int. So it is still deducing it as without the int. I thought that would figure. it really does not want to deduce it as const. All right, so I'm going to leave that as a thing for the message board afterward, because we're running out of time here, and I definitely want to get onto the assembly portion of this. This is definitely what I would consider more in the realm of trivial, and not something that we'd want to be building into our code base to begin with. But just to give a quick overview of what I just did here, this is called a deduction guide. If you want to look more into that, there are times where you might not be able to infer from the constructor directly all the parameters of the template of the class that you're constructing an instance of. In those instances, you need what's called a deduction guide. And that is a means by which to say that for a particular other form of a what it amounts to a constructor call, what type that should map to. Not something you have to do very often, but something that you may need to do at some point. So the word there to look up is deduction guide. Since it copies the hint, it doesn't deduce the const, I think. Yeah, it's something along those lines, Max. I think you're right. Yeah, I was trying to force it to see the parameter as const, but it must be decaying it in a way that I was not aware of. Okay, so keeping those things in mind, let's take a quick look at what we might be able to do with some of this stuff that we've talked about so far to date. So what I'm going to be trying to solve here, kind of looking into or building the basis of, is considering when a platform that we want to build where we want to be able to retrieve and store objects from JSON-based config files. So I'll tell you right now that I've had in previous lives, in real life, a lot of success using Boost Property Tree with a thing like this. And that is definitely something that can give you, as we'll see, some nice separation of within a larger code base, and give you a nice way to kind of express what your configuration objects look like without having to do that all in a collected central area. The basis of a config file is like a JSON config file is you've got a key value pairs, just all sorts of key value pairs. They can come in all sorts of hierarchies. You can get lists of them and stuff. But the gist of it is that I want to associate keys with values. Those values could be ints, they could be strings, they can be all sorts of stuff, lists of other things, dictionaries of things. But the gist of it is it always comes down to a key and a value. I'm going to want to talk in terms of those, and so I'll jump down here a bit to how I kind of want to express this. That within my application, there's going to be one configuration object that has maybe an int and a double that it needs to store off or read in. And there's a second configuration object for some other feature within the application that needs a string. I particularly really love declarative style code that just kind of captures as succinctly as it can the knowledge of what is needed in order to process this thing. So here I'm going to, I really should have used different words here because I don't want to imply that this is telling me the type. Some float val. Then I've got a couple of elements within my config file where the keys are going to be my int that goes off, that should go into my configuration object, the integer value. And then there's going to be some decimal value that I want to get populated into D. So these are the keys. Then in the second configuration object, I want my pet name or something like that. Don't get too distracted on things, but that's going to get stored off in my string. my name and my age in gigaseconds. All right, so these are, maybe I'm reading in some information about myself. Here's my pet, and that's going to be used to create my pet object later on. This is going to be used to set up information about who I am, right? This is as succinct as I want to try and get it to, because I'm going to allow then the configuration system itself to operate on this knowledge that these key value pairs go to this config. Like, that's as much as I want to have to say about it, and let the configuration system handle it from there. The way I'm going to do this together, I should point out here, but we just talked about using ctad. Now, in this moment, I don't have to, because of the magic of ctad, I don't have to say what this key value pair actually has here. So if later on I want to go and change in my configuration what these things are, I can do that without having to change around the knowledge of what key maps to what value, right? Because now this key value pair, I don't have to explicitly say that this is for an integer and this one's for a double. So later on, if I change what these are, this remains consistent. But some machinery is going to be needed on the back end for that. What I'm returning here is a params object, which is basically an object that has a list of key value pairs. Maybe it's a dictionary of key value pairs as the thing gets more sophisticated, or a list of key, or other, you can build it into a hierarchy if you need to. But the gist is I have to return something, because in my usage of this later on, I'm going to want to take my config object, pass it into something from my configuration system, and be able to do stuff with it. And here I'm going to just give it the ability to print out my configuration object to begin with. What that looks like is I need to actually define what my params are. My params, I'm going to need a vector of them, and I'm going to construct them, and printing them out means just going through and calling print for each value in those values. To store them off, though, we're going to use our good old friend type erasure to make sure that we have knowledge, that we retain that knowledge of exactly what types are used underneath. And to do that, we'll create a type erase param using the model and concept stuff that we talked about in the last session. I'll need the ability to clone it, which again we also talked about, and print is going to show up 3 times within that interface. In the top level interface, the concept and the model, and the actual storage of it down in the model is going to give us the ability to just call print line, giving the key and the value at that point. Notice that this model can store any type of value. I didn't have to define any int version, double version, string version. Anything that is ultimately going to work with print line, with formatted printing, will work. So I will likely never have to go back and actually muck around with this, at least until I want to add something beyond just printing. So following this through now, when I create config of C1, it will use argument dependent lookup to go and find my version of config for C1, which will create a config params just off of this initializer list, and it will give that 2 elements, both key value pairs, each of them with a different type. So this key value pair is going to have a type of int, parameter of int for the value type. And this key value pair is going to have a value type of double. So those key value pairs are returned back in the config params object. Config params is passing each of those key value pair objects off to a type erased params. so that I can have just a vector of any sort of parameter, which will allow me to go through and print for every one of those values the actual thing. And so off of config 1, where I had an integer and a double, one of these type arrays, the first type arrays param is going to be instantiated with an int, which will create the new model for int, which will store off the integer inside of itself. And when the print function is called on its base class, the concept, then that will dispatch via the virtual function down to the integer version of this print function. This means that I can change the value of I and then print the thing out again, and I should get the updated version of that. Some of them what we see is that, yes, my name is 10, my age in gigaseconds is 3.14. I'm very, very new, apparently. My pet name is Hello World. And then I changed my age to 25 and printed out again, and those things remain. So this is a means by which we can see, or so what I'm looking to show off here is that we can get ourselves into a nice terse, simplified expression here, managing these config objects, where I can now put my config objects in a namespace alongside the interpretation of it. The interpretation of it doesn't need to be explicit about what the underlying values are, what types they are, so that gives me a little bit more flexibility to change this stuff around without having to mess around with the configuration specification. And I can tell you right now, the spoiler alert, this allows you to then go with this exact same expression, read all the back from a JSON file sort of back into these objects without having to define more code for the configs themselves. Because what we're ultimately looking to capture, and ideally nothing more, is what the structure of the config object is like, and then what the key value pair mapping is. And that is all I, as a user of that config system, that's all I should really have to worry about. Ta-da! Questions on that? Microcentury versus gigaseconds, yes. Turns out I am about a quarter of the way between my first and second gigasecond in age. For those that like to make fun of us Americans for using for not using the metric system, I would like to remind people that years are not metric, that seconds are metric. And so if you want to talk about your age and you really love the metric system, you probably want to be talking in terms of gigaseconds. So that's my little soapbox. Other questions I can answer? All right. Well, I want to thank everybody. So again, next week, Victor Eichhout will be talking with us about some OpenMP stuff, which I'm really excited about. I'm not going to expect him to also try and figure out how to use YouTube Live. So we'll figure out the ergonomics of that this week and let you guys know more about how we'll handle the Zoom session, stuff like that, unless he really wants to do YouTube Live. So thank you for helping me trial run all this. I'm looking forward to getting on to some new cool content with some really good presenters that will be scheduling out here soon. Again, stay tuned for more information on that. The video for this should be live a little bit later today. Those are pretty easy to turn around now, so if you could take a look at that, that would help us out. Spread the word on this. And if you are someone who is willing to put in some uh, just a little bit of time to helping everybody else out and willing to, set up a social event, again, please let us know and we can help spread the word on that. Cool. Thanks all.